Here are some techniques to increase the accuracy of your measurements and improve the reliability of your science investigation. Measuring the mass of a paperclip using a triple beam balance. First, we need to take a measurement with nothing on the balance. The balance's three slide masses are all on zero, but the pointer line on the right is not aligned with the zero line. Move the smallest sliding mass until it's pointing to zero and take the reading. 0.3 grams. This is our zero reading. Record it. This tells us that every mass we measure will be 0.3 grams too high. This is called a zero error, and we'll need to correct for this. Now a paperclip. Place it on the tray and move all the sliders until the pointer is in line with the zero mark. Take the reading. It's in between 0.7 and 0.8, but closer to 0.7, so that's what I'll record. Record the reading and then subtract the zero value. 0.7 minus 0.3, so the mass of the paperclip is 0.4 grams. We can make this measurement more accurate. We'll find the mass of 10 paperclips and then divide by 10 to find the average mass of one paperclip. The mass of 10 paperclips is 4.5 grams. Subtract the zero error, so that's 4.2 grams. So the average mass of one paperclip will be 0.42 grams. We could measure the mass of even more paperclips. Okay, so let's take 50 paperclips. I'm moving the 10 gram mass. It's more than 20 grams, but less than 30, so I move the slider back to 20 grams. And then I'm just doing the fine tuning with the smallest sliding mass to get my final reading. 21.4 grams. So correcting for zero error, that's going to be 21.1 grams. We'll find the average by dividing by 50. 0.422 grams, that's to three significant figures. We can get a more accurate measurement on the electronic scales. First we correct for any zero error just by pressing the zero button. 4.2 grams, wait for it to settle, 4.1 grams, to two significant figures. How about we try using multiple measurements? Let's do 10 paperclips this time. Or even more, 50, 45, 46, 47, 48, 49, 50. 20.40, don't forget the zero on the end. Divided by 50, that gives us our average mass. So, by choosing a more accurate measuring device, and by measuring multiple paperclips, we've increased the accuracy of our mass measurement by 1,000 times. Here are some other examples of choosing more accurate devices. This ruler has a centimetre scale and a millimetre scale. The millimetre scale is more accurate. This multimeter has a different scale setting. Use the smallest one possible. The scale of a wall clock is 1 second. A stopwatch measures to 1/100th of a second. Other examples of taking multiple measurements. To find the thickness of a piece of paper, measure the thickness of a stack of paper, then divide it by the number of pieces. If you're measuring the period of a pendulum to swing, why don't you time it for 10 or 20 swings and then divide the time by 10 or 20?